Hello everyone and welcome to today's Energy Storage News webinar with CEA, Clean Energy Associates, where we're taking a deep dive into best procurement strategies with some excellent guidance and advice on how to navigate this often complex landscape. I'm Andy Colthorpe, Editor of Energy Storage News and Deputy Editor-in-Chief of Publishing at Solar Media. Over the past decade that we've been covering the global industry, we've seen so many market-shaping trends. These have had an impact on both ends of the business case for batteries on the grid. What I mean by that is that on the one hand, there are observable trends in the factors that impact the ability to acquire, deploy, and operate battery energy storage system, or BESS, components and solutions. And then there are observable trends in factors that impact how much value they can provide once they're commissioned and in commercial operation. So we've seen costs plummet over the years, with the notable exception of the mid-pandemic lithium and logistics price spikes. And our expert speakers can give you more details on that. And in the meantime, we've seen policymakers, regulators, grid operators, and utilities come around to the value of energy storage in a growing number of markets too. But of course, it's much easier to talk about what's happened historically in an industry than it is to tell you what will happen in the years to come. Again, that's where today's expert speakers come in. And I guess they would agree that while forecasting the market is very useful and a great indicator of how things might develop, given certain circumstances and conditions, it's simply impossible to predict the future accurately, and forecasting is never ever going to be 100% on target. What you can do, however, is gain a deep understanding of the fundamentals of the industry, the technology, the suppliers and manufacturers, the raw materials and the processes. That will equip you for a range of outcomes and scenarios that the markets you work with might face, and ultimately put in place the conditions for success while mitigating the risks. Today's speakers are Jeff Zwijack, Associate Director for Energy Storage at Clean Energy Associates, and Aaron Marks, CEA Market Intelligence Consultant. Unfortunately, CEA VP of Customer Solutions, Jeff Burkett, wasn't able to make today's session as advertised due to unforeseen circumstances. In today's session, presentations from Jeff and Aaron will be followed by a panel discussion in which I'll be asking some questions of my own, as well as picking out questions from you, the audience. So please put your questions for CEA in the questions tab that you can see on the right-hand side of your screen, and we'll try and tackle as many as we can in the short time that we have. Anything we don't have time to answer, please rest assured CEA will be more than happy to reach out to you and follow up and continue that discussion offline. And if, like me, you're heading to California next week for RE+, the biggest clean energy trade event in North America, you'll be able to use this webinar to prime yourself with the latest data and insights that will help maybe frame conversations on the exhibition floor and conference halls. Clean Energy Associates will themselves be attending RE+, of course, and you can get in touch with their speakers after this session or visit their booth to learn more firsthand. And finally, from me, this webinar is being recorded and will be available to view on demand from the Energy Storage News site in the coming days, and presentation slides will be sent out to registrants. And so with that, it's my great pleasure to hand over to our first speaker, Aaron Marks. Over to you, Aaron.
Thanks, Andy. As Andy mentioned, my name is Aaron Marks. I am a consultant on the market intelligence team at CEA, where I focus on energy storage and the energy storage supply chain. So before we get into a more in-depth conversation about storage procurement, I'm going to provide some context around what's going on in the energy storage supply chain and why we expect that procurement is likely to become a bit more complicated in the coming years. To begin framing this discussion, we can start by discussing the origin of most batteries and battery energy storage systems that are being procured today, which is China. Now, as the energy storage industry began to mature, starting out towards the late 2010s and moving up through into the early 2020s, we did see the share of imports coming into the United States and North America broadly increase when it comes to systems that were coming from China. Now, given who many of the major so-called tier one players are in battery manufacturing, it's unsurprising that we've seen the share increase. There have been benefits both in terms of technology when it comes to what you're actually procuring, as well as benefits in price, given the relative cost of manufacturing an energy storage system in China as compared to manufacturing said systems, say, in the United States or in Europe. Now, this sort of trade profile in terms of technological items being exported from China and then imported into countries like Europe and the United States is somewhat of a familiar one across industries. But with batteries in particular, both for energy storage and for electric vehicles, there has been somewhat of a trade policy backlash, especially here in the United States. Back in May, we saw that the Biden administration imposed increases on the Section 301 tariffs, specifically on lithium-ion batteries, certain other battery parts and feedstocks, and electric vehicles in general. Now, for non-EV batteries, in which case we're mostly talking about batteries that are destined for energy storage systems, this new tariff will become effective at the beginning of 2026. Whereas for most of the other new tariffs, it is or has been effective since roughly August, although there has been some back and forth in the USTR regarding that. Still, it does mean that the battery storage industry has a short period of time in which they can adapt to these new tariff costs if they are to continue importing battery energy storage systems from China. As is to be expected, this has meant that developers and integrators, as the primary purchasers of batteries from Chinese OEMs, have begun to change their strategy and are looking for alternatives as a way to mitigate some of the impact of these tariffs. Now, this could range from completely changing the country of origin for procuring a storage system, or it could be procuring a system that has a somewhat different bill of materials when it comes to not only the batteries, but also the broader balance of system. By procuring a system that is integrated elsewhere, even if the batteries still come from China, that does mitigate a bit of the tariff exposure. So that is one of the strategies that we have seen. However, one of the broadest impacts that is not entirely caused by trade actions, but is coming hand in hand with them, is the increasing quantity of domestic manufacturing for batteries that is happening both in North America and Europe. As we look forward out to 2028, we're seeing significant projected manufacturing capacity coming online, over 200 gigawatt hours in both North America and Europe. Although, compared to the projected demand for batteries coming online at this time, it's likely that there will not be enough domestically produced batteries to meet demand coming from energy storage. Further complicating this, although lithium iron phosphate is the chemistry of choice for battery energy storage, it is seeing increasing adoption in the electric vehicle sector as well. So, while these charts show potential LFP production capacity in North America and Europe, there is a likelihood, in fact, it's known, that a good portion of these battery manufacturing facilities are going to be for EVs. Now, this may be somewhat surprising to a consumer in the United States who is more used to seeing high nickel chemistries for use in EVs. But LFP as in electric vehicle chemistry has been increasing in popularity throughout the world. And as a result, we are seeing that more of these LFP batteries are going to be manufactured for EV applications, which does put additional pressure on making sure that the demand for batteries and energy storage is actually successfully met. there is another development that is further complicating the battery supply chain. And this has to do with the continuing search for other potentially low-cost manufacturing centers other than China for battery manufacturing. As we're looking forward, once again, out to 2028, we're seeing that the same sort of trend that is stimulating domestic manufacturing capacity in both Europe and North America has also led to investment in battery manufacturing capacity in the Middle East and in Southeast Asia. Now, broadly, the trend is going to be similar in that we're seeing a lot more interest and investment in electric vehicle batteries than in energy storage. However, there are a couple of plants that we are monitoring that are going to be manufacturing cells dedicated towards energy storage, including one from EVE Energy in Malaysia and another one from REPT in Indonesia. Since the plant in Indonesia is scheduled to be online in 2025, we have already seen integrators in the United States contracting for these cells to make their way into US integrated energy storage systems. This does have the potential to change the pricing calculus, especially if it means that the tariffs, both the tariffs that are currently in effect, the 7.5% Section 301 tariff, as well as the higher 25% Section 301 tariff, these tariffs would be avoided from manufacturing cells in Indonesia. The other issue is one that somewhat parallels the solar industry. In the solar industry, we have been having a lot of news and discussions regarding the new AD/CVD proceedings, that's anti-dumping and countervailing duties, regarding solar panels that are being manufactured similarly in Southeast Asia. Now, there is a potential that the energy storage industry could follow in this path. However, at this point, it's unlikely that there is a party that's likely to initiate AD/CVD proceedings against a battery manufacturer in Southeast Asia, especially given the relative infancy of this portion of the industry. However, even if that is not a risk at this point, it still illustrates the fact that the increasing fragmentation of the battery supply base, as well as these changes in terms of where batteries are coming from, are going to make your procurement process ever more critical for reducing uncertainty in terms of actually getting systems online and deployed. So with that, I am going to turn it over to my colleague, Jeff Zwijack, who is going to talk about the procurement process in more detail. Thanks, Jeff.
Yeah, thanks, Aaron. Thank you, Andy. So my name is Jeff Zwijack. I'm the Associate Director of the Energy Storage Group here at CEA Clean Energy Associates. Been with CEA for a little bit more than 3 years. Prior to that, I was with an integrator for almost 4 or 5 years. And then I was a plant manager of a very large manufacturing plant for almost a decade. And then a little bit before that, so IEOE work. Telling you this is because I lead the energy storage group in IEOE, quality assurance and supply chain support. So that's in procurement. So what we do is we have a 4-phase proven process to procuring energy storage equipment. So today I'm going to talk about those 4 phases. So first, phase 1 is the request for proposal. Very important to beginning a project, beginning a procurement, any procurement activity. Phase number 2, due diligence, either on that shortlist or that selected supplier. Phase number 3, contract. So you want to review those contracts, review those MSAs, all those exhibits that accompany that MSA. Phase number 4, quality assurance support. So that's on that selected supplier. After that negotiation, go there, boots on the ground, factory audit, inline production monitoring, factory acceptance tests, and we'll get into all those phases a little bit later. So phase number 1, first thing you want to do, understand your project, understand the use case. Is it a merchant market activity? Do you know the ancillary services? Can you predict what sort of ancillary services there will be on the project or portfolio? Use case, PPA. What does the PPA say? can we take the goods from the PPA and move it directly over into that request for proposal or request from tender? Also, in creating that RFP, we want to be as real as possible. So give information like the land. Has the land been acquired? What's the status of the land? Is it under your ownership? What's the interconnection status look like? Has it been completed? Is it pretty much solid with a particular size, AC size? Give as much detail as possible. With as much detail as possible, there's also some sort of assumptions. When you write a request for tender, request for proposal, typically those bidders will assign some assumptions because they're unknown, whether that be line losses, where the point of interconnect should be or will be, what the AHJ wants or will want in the future. So instead of having that ambiguity and having the bidders, provide those assumptions, how about you create those assumptions? So right inside that proposal, request for tender, some assumptions that everyone can agree, can bid upon themselves. Scope of work, full design criteria. So what sort of equipment do you want or do you need? What are the safety standards? What are the requirements from the AHJ? Or if you haven't spoken with your AHJ, what are some past projects in the county or in the state or in that local jurisdiction? What does that look like? What are you looking for in shipping terms? Very basic. Tariffs and duties. So who's going to pay for the tariffs and duties, and what percentage of those tariffs and duties are you taking on? What percentage of tariffs and duties is that seller going to be taking on? And is that correct? Reach out to a third party, see what those tariffs and duties are currently. Very important, division of responsibility. You want to make sure that not only do you have a column set for yourselves, which is the buyer, but also the EPC and the integrator. So if you're buying an integrated solution, what are they responsible for? You're going to an EPC, what are they responsible for? You go in for a combo of EPC integrator and integrated, what are they responsible for? What is the engineer of record responsible for? The next thing in the RFP creation is that timeline. You want to be very specific with your timeline. What does that initial bid period look like? Is it 2 weeks? Is it 3 weeks? Is it 4 weeks? What does that review period look like? Typically, we like to have 2 weeks for that review. After that's the best and final offer. So let's just say you're reaching out to 6 suppliers. You're coming out with 2 or 3 shortlisted. You want to get that best and final offer from them. Leave a lot of room for contracts. 3, 4, 5, 6 weeks for contracts, depending on what has been done in the past. Are there term sheets available that's already been worked on with that supplier or suppliers? All backed up from the what I would call the fixed dates, which is the delivery or COD. So once you send out that RFP, it's gonna take 2, 3, 4 weeks to receive bids. What do you want to do with those bids? You want to normalize those bids. But before you normalize those bids, you want to identify any missing information and send out an RFI, request for information, from those bidders. We ask in that tender form, we ask all the right questions, but something may be missed. So you want to identify what information is missed. Compare and contrast designs. Not everyone's design is going to be the same. Not everyone's designing with a DC block. Not everyone's designing with an AC block. Not everyone is designing the whole integrated system. Some may just provide the DC system, and then you need to go to another party for your inverter and transformer. So compare and contrast designs. Look at the vendor profiles. What does their cell flexibility look like? Are they only tied to one battery cell? Is that integrator only tied to one battery cell, or are there multiple battery cells that's within their supply chain that they can pick from? What's their availability look like? What's their capacity look like now and in the future? Where is their factories? And what does their factories look like? Do they own those factories? Are they vertically integrated, or are they going out to what we would call like a job shop to build and integrate your container, your rack, your module, what have you? And of those firms that are building your systems, what's their profile look like? What's their bankability look like? Talked a lot about design profiles. Obviously we also want to talk about pricing. What does their pricing look like? Aaron and his team have a pricing forecast tool that we can take that bid and mirror it up against our pricing forecast tool, what it looks like for the next few months. Are they using a raw material index? Is there a certain timeline, expiration date to that pricing, and when does that pricing get locked in? So after BAFO, best and final offer, you have your selected suppliers, or maybe just one. We recommend more than one, at least a backup. You want to have some due diligence on that supplier or suppliers. So engineering reports, what does engineering reports look like? Look at the current, look at the future. What's their bankability look like? Do a SWOT analysis. What do their strengths look like? What do their weaknesses look like? Go there for the factory audit. Go there, look at the factory. Either yourselves can go over there, or you can have a third party go over there, wherever that factory may be. That could be in Europe, could be in India, could be in China, could be somewhere else in Asia. Next thing you want to look at is their code of conduct. Not just on paper, their paper code of conduct, but look at their product. Look at their traceability. So not only their enclosure, but what's inside their enclosure, rack, module, all the way to the battery cell. So what a third party should do is, when they look at the battery cell, look at downstream all the way to upstream. So that anode cathode separator material all the way upstream as far as you can. We have battery cell suppliers that work with us very well. We have some that are a little bit more difficult to work with. We know what questions to ask. And that's very important for a third party, is knowing what questions to ask in order to get the answers out of them. If they are very reluctant in providing you with that information, maybe there's other avenues. Maybe it's out of a teleconference, or maybe it's going to their factory locations and sitting down at a conference room table and discussing what their supply chain map looks like. So after that due diligence is completed, you go there for the factory audits. You're happy with that supplier or suppliers. You want to get into contracts. So what's in a contract? The master supply agreement, that could be under a couple different names. That could be just called supply agreement. That could be called battery supply agreement. Could be called master supply agreement. They're relatively all the same. The master supply agreement or supply agreement really just as a framework, is a roadmap or a flow chart of how the rest of the documents should work together. You got your basic stuff like terms and conditions, items like that. But the meat of the MSA is within the exhibits. So you'll have dozens and dozens of exhibits. Some of them are blank forms just to be filled out during the project, but a lot of them are the meat and potatoes of the project. So you have the scope of services. What are you buying from them? What's the quantity? What's the bill of material look like? You want to be very specific in the bill of material. Are you buying last year's model, or are you buying this year's model? We've seen that all the time where the models get confused. Division of responsibility. So who is doing what and at what time? Last thing you want is to get into the field and have a piece of equipment being shipped there from whatever party, and then everyone's pointing fingers. I thought you were supposed to install it. No, I thought you were supposed to install it. Or where are the cablings for this equipment or that equipment? So a lot of finger pointing. Get into the damages. Damages are very important in case of stressful situations. So we always talk about the liquidated damages, what the caps are, who owns that. Performance guarantees, availability guarantees. So the availability guarantee, we like to hammer that in the RFP or request for tender process, but we relive it again during the exhibit portion of it. So availability guarantees and performance guarantees. Also failures. Again, you want to any type of product failure. What's that flow chart look like? LTSAs, long-term service agreements. They could be under a couple different names, but they're all mean like an O&M contract. So that O&M contract, either that's with your integrator or it could be another party. A lot of integrators wrap together the O&M contract with their master supply and exhibits, but it's a separate contract. Typically 20 years. It's a 20-year project. So you want to look at things like preventative maintenance. What does that mean? What's the definition? What's the cost of that? Corrective maintenance, same thing. What does that mean? What's the cost? Corrective maintenance, what does your time look like to fix something as part of a corrective maintenance? Warranty correction, what's the procedure look like? Let's run through some scenarios. If a battery module were to fail, are you going to replace that module? What if that module is not available? Well, do we need to point back to the LTSA or point back to the exhibit? How does that integrator make you whole if there is a warranty issue? Another item is remote monitoring and diagnostic, which is your support system. So who is watching that? That could be your integrator, or that could be another third party. So contract's very important. So why should you care? So I think I mentioned before, in times of stressful situations, you want something to point back to. You don't want to be head scratching. You don't want to be pointing fingers. You want, in times of stressful situations, you don't have time to think. All you need to do is go back to that exhibit, go back to that document, go back to that signed contract, point to it, and it'll provide you the answers. So that's what good documentation does. What is bad documentation? Bad documentation, if you don't have a clear division of responsibility, well, that could be costly. Not just for the project, the portfolio, but also maybe even PR. So some best practices for contract reviews. So not only do you want a technical advisory firm to help you in reviewing, redlining those PV and BESS contracts, we also want a legal firm as well. Technical advisory firms have reviewed a lot of contracts for a lot of buyers in the past, whether that be integrator buyers or developer buyers. Third-party integrators definitely use them to help you out with redlining. Also very important, I mentioned way earlier in phase one, is scheduling. We see it time and time again where if there's a fixed COD, fixed delivery, you spend a lot of time in your RFP process, a lot of time in your third-party due diligence process, and therefore your contract review is shrunk. You want to extend that you want that as large as possible, 5 weeks, 6 weeks, if possible. Countless times where we see, hey, we only have 2 weeks to sign a contract, and we rush through it to sign a 20-year contract. So who does that get leverage to? It really gives leverage to the seller. So you want to give as much time as possible to review those contracts. Mentioned earlier, not just work with a third-party technical advisory firm, which is technical. Also work with your corporate counsel or another legal services to review those T's and C's, the firms that know your company best. After phase 3, we want to jump into phase 4, which is quality assurance. So quality assurance can mean a couple different things. I talked about factory audits before. We really want to go back and redo that factory audit. We call it a shelf life to that factory audit. So during that initial supplier selection phase, we want to do that first initial audit. We want to look at who we're getting involved with. But this factory audit, we want to look at other things like their quality process and their SOPs. Next thing we want to look at is their inline production monitoring. Also want to look at their first article. So after that inline production monitoring, where we look at your product, we also want to look at the first article that's coming off the line. Also with that, after the first article coming off the line, we want to do some sort of sampling with the factory acceptance testing. So first, that factory audit. We want to look at the system and the process. So the system, including their social responsibility, looking into their supply chain, looking into the manufacturing practices, looking at their EHS, looking at the process, looking at what happens with an RMA. What does your shipping and receiving look like? Everything on the right-hand side, is a good document list to sort of use as a guideline when reviewing their documents. You want to look at all their SOPs. Factory audit is very important to do before they start making equipment. Reason why we want that is because anything that's found in the factory audit, we can have them fix. They can fix before they start making your product. It makes sense. So again, you want them to fix the findings before they start making your product. That's why that factory audit is very important. Next thing we do after that factory audit, there is a couple different phases within that inline production monitoring. So first, going back to that factory audit, phase number one is go back to that factory audit. Is everything that was found, major, minor, critical findings from that factory audit, is all that fixed? That's phase one. That's that pre-integration and quality control. Phase number two is really that inline production monitoring, where we monitor the product that's going through the line being built, whether that be a cell that's going into a module, the module going in the rack, that rack going into the container. We look at the entire thing being built. We monitor it, and we randomize it. We don't want to be there full, 8-10 hours a day for the life of the production. That's not what we want to do. We want to pick some sort of sample size that works well. Phase number three, we want to look at the post-integration. So that is quality points during the production process. So when the cells go into a module, that module gets tested, has some sort of quality control that's on the line. When that rack goes into the container, there's some sort of quality control process that the factory has. We want to look at that quality control process. It's not an FAT. It's just that post-integration part of that inline production monitoring. Finally, we get into the factory acceptance test. Fairly widely known, for a quality control process is the factory acceptance test, FAT. So what do we want to do here? We want to witness and view a certain sample size of that product being made. What is that sample size? We go off of AQL tables. It's a statistical table. Typically 10%. That's the sample size. So let's just say you're buying 100 cabinets. We want to do a witness FAT on 10 of them. That could go down. That can go up. Let's just say we see a little bit of poor quality coming out of the 10. We may want to hike it up, and that's the same thing on the other side too. But that factory acceptance test is very important. Not just witnessing, but all their documentations. What sort of testing are they doing? So we want to review all their documents around their FATs before they do the FATs. So do some sort of a gap analysis. Are you doing this test? Are you doing that test? Let's look at where the project is being put. Is there certain tests that the HJ wants to see? Let's perform those during the factory acceptance test, which is a lot easier to do testing in the factory than it is on site for the site acceptance testing. So with that, I turn it back to Andy. I just want to thank you very much for listening.
That's fantastic. Thanks so much, Jeff. And yeah, really great presentations from both yourself and Aaron, and given our audience not just plenty of insights and information, but also some food for thought. So we've got some terrific questions coming in, lots of questions coming in. Obviously, as I said at the beginning, we won't be able to address all of those in the time that we have, but the CEA team will be happy to reach out to everyone that's asked a question and follow up that discussion after the session. And in response to all the folks that have been asking if the session's being recorded, yes, it very much is, and you will be able to watch it afterwards on demand at ESN. So with that, yeah, we'll start with a few questions from myself, and then I think we're going to start interspersing those with some of those great questions from the audience. So yeah, I mean, I think to begin with, you know, we looked at sort of, so Aaron, you kind of introduced us to the big picture, but yeah, I mean, amid fluctuating demand for electric vehicles, you know, we had huge spikes during the pandemic to say the last few months where it's been still good adoption rates, but much lower than some people had thought about. So how hard is it to predict battery availability? And what's the impact that then has on pricing, especially in the light of the introduction of the raw material index pricing that kind of came into the market a couple of years ago?
Sure. So there's a couple parts to that question. If we're looking broadly, I know the questions around availability really do stem from what was going on in 2022, where a lot of these price spikes were driven by the fact that there was only, you know, so much manufacturing capacity to go around. And the environment is a little different now. If you're looking towards kind of the core manufacturing base we talked about, which is, you know, cells being manufactured in China, you often do have some of these factories running at lower utilization rates than, you know, will be considered full capacity. There is some back and forth whether this should be called overcapacity or not, but regardless of whether we use that term, the point still remains that there is more flex in the manufacturing base in terms of adjusting to increasing demand. Now, to the second part of the question, which is around pricing, some of the price declines we have seen have been because, you know, there's been a shift in the supply-demand imbalance. And part of that was that a lot of the investment upstream, not only in cell manufacturing, but up to cathode and anode active material processing, and yet further up to lithium and graphite extraction, was driven by those high prices in 2021 and 2022. And although the coolant prices from last year and this year did kind of also cause some of that investment to cool, a lot of these facilities further upstream are still coming online. And the result there is that we're kind of seeing a very different supply-demand picture than we did in 2022. Now, as far as index pricing goes, you know, if we're looking back to 2022, index pricing was essentially a protection from cell OEMs, knowing that prices were going to change and change drastically enough that over the process of securing a contract, you could have, you know, a 5, 10, 15% increase in cell prices as a result of the lithium prices going up. So the OEMs worked this raw material indexing into their contracts as kind of a protection. Well, in the past year and a half or so, the reverse has really been happening with prices. And as a result, you now see, you know, developers and integrators like, hold on, let's keep doing that raw material indexing thing, because now it's the lithium prices potentially going down. So they want the protection to know that they're still going to get the best possible price. And there's going to be back and forth on that. But because we do see this volatility, and that sort of indexing offers some degree of protection to both parties, depending on which direction lithium's going, it's likely to stay in contracts for some time to come. Now, on the final question about that, you know, predicting what's going to happen going forward, because we have seen such an increase in capacity, and this is at all stages of the supply chain. We've seen an increase in lithium mining. We've seen an increase in processing capacity. There's continued investment. You know, I showed the chart showing North America and Europe and Southeast Asia. Well, the charts for, you know, midstream processing capacity and upstream extraction capacity don't quite look the same, but they are all showing growth trajectories. And as a result, as we do look forward within the time frame that we can, and typically at CEA, we like to publish our forecast out maybe 5 years. Because anything further than that, and there's just so much more uncertainty that it becomes difficult to say that the numbers are really that meaningful. But within that 5-year time frame, we don't really see any likelihood of returning to the sort of pricing environment we saw in 2022. Prices are likely to go up, but just not anywhere near the magnitude of what happened a couple of years ago.
Okay. Thanks a lot, Aaron. Thanks a lot. So, I think we definitely want to avoid kind of political speculation of any kind, really, I think. And it's always healthy to avoid that, I think, in general, unless, maybe you're on a late night social media session or something like that. But, in terms of, I think for a lot of people, the elephant in the room a little bit is the upcoming US presidential election. And I guess, it would be a little bit remiss to not think about that for just briefly, I guess. But, what might the potential impacts of that be? And I guess other big picture political factors in kind of general terms, really, I guess.
Sure. So I think when you're looking at what's happening in politics and policy, the important backdrop we need to look at is the fact that we have seen recent trade actions, especially against China, in the last few months. I discussed a bit about the Section 301 tariffs in the US, but there were also tariffs on EVs introduced in Europe, and Canada followed suit with their own tariffs on EVs as well. So there is some sentiment about kind of a little more building up these protectionist walls when it comes to trade policy. And what that means is, given the fact that, as an example, in the US, these new tariff hikes happened under a, Democrat presidential, blanking on the word, and that's ridiculous. Administration. Wow. Administration. They're happening under a Democratic administration, and that was something that analysts did not initially expect. And we were caught a little bit off guard when this did happen back in May, kind of assuming it was going to be a little more partisan than it was. This isn't to say that if we see a change in administrations in November that we aren't likely to see changes in trade law. As an example, we could very likely see further increases in tariffs. There has been some rhetorical points made around 100% or 200% tariffs. Whether or not that's particularly feasible or economically ideal is somewhat besides the point. They were just made as rhetoric. But it does go to show that the intent is likely to be different if the administration changes. However, it is important to note, given what we've already seen, that if we do have another Democratic administration come January, the fact is that we're still likely to see some potential protectionist trade policy, which could introduce additional risk. So I don't want to claim that the two outcomes are the same. They most definitely are not. But at the same time, it's not necessarily clear cut that things will be smooth sailing in one direction and less so in another.
Yeah, absolutely. I think, like a lot of things, political landscape can actually be a lot more nuanced than sometimes appears on the surface, I guess. So so moving on from that, and I guess to some extent we'll have to wait and see. The question I was going to ask, I want to also throw in a question from the audience as well. So you did allude to this a little bit in your discussion around the push for factories based in Southeast Asia, Aaron, and not just Southeast Asia. I think the phrase you used was, low cost manufacturing basis. But yeah, nonetheless, with Southeast Asia, we've seen in the solar industry, the AD/CVD, so the anti-dumping countervailing duties saga that has, it's carried on for quite some time. And we just wonder if something like that might be echoed in the energy storage industry. But if I could also, as I say, throw in an audience question, Samuel asked, and thank you very much for your question, Samuel. In case European battery energy storage suppliers manufacture cells internally, uh, would they, or I guess could they be price competitive against Chinese supplier factories outside of Europe? So a little bit of a double whammy question there. I hope it's fair to kind of bundle those together, but I did want to get Samuel's question across because, I thought it was a pretty good one.
Sure. So first on the AD/CVD saga, as you mentioned, they say that history doesn't repeat itself, but it does rhyme. And so, being analysts in both solar and storage, we at CEA are kind of watching what's going on in the battery manufacturing space and looking at the comparisons to what happened in the solar manufacturing space pretty carefully. What needs to happen for a anti-dumping and or countervailing duty case to be initiated in the US is you need a petitioner. You need someone who's basically filing that suit and saying these companies are acting non-competitively by either dumping, putting on a lot of product below cost, essentially, or operating in a country that gives them an unfair degree of internal subsidy, which would allow the US to initiate countervailing duties against that subsidy. So that you got the AD, you got the CVD. But what you need for both of those cases is someone to actually file suit. So in the case of the US solar industry, there are domestic solar manufacturers that filed these AD/CVD cases and basically saying these companies are acting non-competitively. And where we are in the battery industry right now is that we just do not have large enough companies, especially large enough American headquartered companies like a First Solar as an example, who would seek to initiate that sort of suit. So you can imagine if we go 5-10 years down the road and we have a more mature domestic manufacturing industry, then there might be one of these companies who files the suit in an attempt to kind of, protect their own business. But for right now, it's just a little premature to see that. We don't really have those sort of stakeholders in the US quite yet. Now, onto the question of Europe, it's an interesting question, but here's one place where the drop in raw materials costs are actually probably going to hinder rather than help. So we've noticed this across the bill of materials, but it's absolutely true around other manufacturing costs like energy and labor, is that as lithium prices go down, as graphite prices go down, as a lot of these commodity prices go down, that means that fractionally the cost impact of things like energy and labor go up, just because everything else is a little less, but they're staying relatively the same. So that does mean that the cost advantage of a place like China compared to somewhere like Europe actually gets somewhat magnified. Now, there's already been efforts in Europe to kind of moderate this. We see battery manufacturing facilities going in places with cheap energy, like Norway, and also with lower labor costs like Hungary and Serbia. So there's already acknowledgement of these sort of cost mismatches within kind of the European OEM community, and there are steps being taken to moderate that. However, given, and once again, like any of our other forecasts, it's just within the next 5 years, given those efforts and the costs we're seeing from some of these European manufacturing facilities, it's unlikely that we're going to see them quite be on par with Chinese manufacturers within the next 5 years. As the industry matures, that could change. More automation, more use of cheap renewable energy. There are avenues to be taken. I will note here that the reason we see more ability for, say, US manufacturers to be competitive really comes down to the IRA. It comes down to those incentives like the Section 45X tax credit, which can pay out $45 per kilowatt hour if you're manufacturing cells and modules in the United States. And right now that is more than enough to cover the gap between a US manufacturer and a Chinese manufacturer.
Okay, wow, yeah. So you said it was an interesting question, but we got a really interesting answer to match that as well, I think, Aaron. And just on that point alone, we could probably do a whole discussion around the competitiveness. I mean, I guess the thing I've heard from folks based in Europe who are far smarter than myself is that a lot of them don't see obviously being able to compete directly with China, but they also think that it would be completely remiss to not have some stake in the within the manufacturing sector that's domestically to Europe. But yeah, so thanks to Samuel for the question, and thanks Aaron for the answer. So coming back into the contracting strategy side of things that you spoke about, Jeff, and this is another audience question. So Colm, thank you very much for your question here. If you could just describe some typical contracting strategies, and Colm gives the examples of full wrap EPC, engineering, procurement, and construction, direct supply of batteries, and what have you. And I guess there's a pretty broad scope of different things that you could, again, could go into a rabbit hole around, Jeff. But yeah, maybe just a bit of an overview there, if you could, please.
Yeah, sure. Thanks, Andy. So I think a lot of it is very specific to your needs and your past history. What sort of energy storage systems have you developed in the past? What sort of lessons learned have you had in the past? What are your successes? What is your company's risk profile looking like? So typically, what we like to do for a very green developer, assuming you're developing, is purchase from that integrator a full wrap, maybe like a wrap of the integrator, someone that wraps the DC, the AC side, and then procure another EPC, and they work together within a division of responsibility that's part of the contract. So you'll have two division responsibilities. You'll have one with that integrator that's wrapping the battery energy storage side of things, and then you'll have another division of responsibility for your EPC. Both of those, the contracts don't talk to each other, but they both have to be in line with each other. Now I get to a little bit, someone that's not as green, maybe have a few projects under their belt, a little bit lower risk tolerance or higher risk tolerance. Maybe you can go to that direct procurement model. Direct procuring the battery portion of it and becoming your own integrator. So purchasing that DC block directly from that OEM, and then having that, and then procuring the integrator, maybe to wrap everything, or maybe not procuring that integrator to wrap everything. Maybe procure your own energy management system, something that you're comfortable with. But when you're doing a direct procurement model, that phase two, that third-party technical due diligence, really plays a big part in that. So not just phase one, understanding what you want, but understanding what you're going to get. And if that's aligned with what you want, is that phase two. So doing that full technical due diligence. I would love to take this offline, because it's very project portfolio and company buyer specific. Again, what your wants are, what your needs are, what's your risk profile look like, what's the company look like, what's your past history looking like, who do you want to work with, what OEMs do you want to work with, and what their bankabilities look like, what their parent guarantees look like. So there's a big huge spider web that we want to help untangle, maybe to answer that question. But excellent. Thank you. Yep.
Yeah, thanks very much for that question, Coleman. Yeah, perhaps you will be able to follow that up with Jeff afterwards. But in terms, Jeff, of let's say the different metrics that developers or integrators are basing some of their procurements or strategies on, are some of them doing that kind of based solely on price and or availability? And kind of, what are the drawbacks to that approach, do you think?
Are there folks buying solely based on price and availability? I'm sure there are. Is it the right thing to do? No, not really. So, and then when you talk about price, what do you mean? The overall cost of ownership? Are you talking about just buying that product? So let's just say you have a guy that's Bob's House Batteries that's wants to sell you a little small 1,000 kilowatt hour container, DC block only. Yet another fellow wants to sell you a 5,000 kilowatt hour DC AC system. Either one can be used for your project. It all depends on what your project size, what your use case looks like. It's not just buying the product, but you also have to install that as well. So that smaller size one for the larger projects, you have to install more foundations. You have to pull more cabling, install more cabling, land more. You have more lines of communication with that smaller. But that smaller one may work well for your smaller DG projects or your community solar projects where you can be granular as possible. For instance, I saw one question in the question column was oversized versus augmentation. Well, let's look at the project size. So that smaller one may work well for those smaller projects. You can be granular as possible and get to exact size you want for that right oversize you want, because I don't want to be tied to an augmentation year. Let's just say I don't want to be tied to year 3. I have in my roadmap, I'm going to augment all my projects in year 5. Well, maybe you can do that with a granular system, or maybe you can't do that with a larger system. So don't just look at the price, look at the overall cost of the system. We put everything in terms of per unit, so per kilowatt hour, normal common use term. But yeah, you don't just want to look at pricing and availability. You want to look at what they're providing you, what size, not just that, what sort of services are they offering you, what's their bankability look like, and not just availability. What's their parent guarantees look like? What's their flow downs of warranties look like? What's their ease to work with? What's that looking like? Do they have local contacts that are within my state or within my county or within my country to work with? Do I need to call China? I don't want to call China, because there's a lot of questions that need to be asked besides just the pricing and availability. So all those questions come into one. That's where that normalization, that's where that second phase technical due diligence comes into play.
Absolutely. And another aspect of all of that is warranties. And I've got a couple of questions I'd like to ask around that, but I think it'd be great to do a quick double whammy of questions from the audience before we get onto that, if we may. So Solcombe was asking, and thanks for your question, Solcombe, which specific terms related to the BESS should we consider in a supply agreement? And then an intriguing question from Mim, who asks, what are the big misses that developers face on BESS procurement? So some of the real pitfalls that you might actually see in terms of BESS procurement, and then also what are specific terms that developers and integrators should consider in a supply agreement?
Great. Yeah, Andy, I can take that one. Just writing this down so I make sure, and then I get to both of them.
Sure, no problem. Yeah,
because
I rolled out a long question there. Yeah, sorry.
Yeah, because I know we only have a couple of minutes. So the terms, what terms you want to look at? It's funny, I want to say all of them, but the important ones. You want to look at availability guarantee. So anything that's really on your, let's just make a scenario. It's a PPA. So you want to make sure that your PPA terms get transferred into that request for tender. So that be your availability guarantee. There could be damages on your PPA. You want to make sure those are properly flowed down to the integrator, and not just that, but making sure the integrator has proper flows, because the integrator is likely not going to be vertically integrated, no pun intended. But you want to make sure that integrator has proper flow downs. You don't want to put all that ownership of warranties and guarantees on that integrator. That integrator should have some put some responsibility on that battery cell provider, or that energy management system provider, whoever's providing those systems. Because not one integrator, unless they're extremely bankable and have a really large parent guarantee and a very large risk tolerance, likely that integrator is not going to take full responsibility of the entire thing. They're going to look to their supply chain to take some ownership of those warranties and guarantees. So, important terms besides just availability guarantee, damages are a very, very important term. Your O&M, what does that look like in terms of terms and conditions? What do your warranties look like? What's your definitions? Let's start off there. What's the definition of a performance warranty? Is that the same thing as performance guarantee in terms of their eyes? Sometimes it is, sometimes it is not. They all talk different languages. So if we're looking at a project, let's work on those terms and conditions as part of that supply agreement. If you're looking at a portfolio, we suggest doing coming to an agreement on a term sheet where we lay out all those important terms and conditions up front into a term sheet, so we don't have to do the same thing over and over and over again for every single project. Some of the pitfalls of contract negotiation support. I mentioned the first one. This is near and dear to my heart because this always happens, is timeliness. We get to the sexy stuff, which is procuring and the phase 1, phase 2 stuff, but then we leave a little bit of time for contract work, and that delivery timeline is fixed. It cannot pass that point, and if we do pass that point, your seller may say, "Hey, your price is only guaranteed for 2 more weeks. Rush, rush, rush." They may use that leverage against you. So I mentioned before, pitfalls. Get your contract, set 4 or 5 weeks together, not just with a third-party technical advisory firm like us to help you review, redline, and negotiate those contracts, but also work with a law firm as well, whether that be a general counsel of yourself or hire a law firm. That's a major pitfall. Another pitfall is warranty flowdowns. I mentioned before, just answering that last question. But making sure all the warranties and guarantees have a proper flowdown. You don't want that integrator to be responsible for the entire project. It may look like it at its face. They are fully responsible. So if you look at the RASCI chart, yes, they are responsible. But if you take a look at their RASCI chart, which you should ask for, look at their RASCI chart, they should have, hey, a battery cell goes bad, I need to go out to this OEM. Battery module goes bad, I need to look at this OEM. Battery rack goes out, this one. Battery management system goes to this one. So look at their RASCI chart, because if you have a product failure within your container, yes, of course, you're going to call the integrator, but you don't want that integrator to spend a week trying to sort things out. Hey, who's responsible on our end for this thing? What do we do? So those are 2 major pitfalls we see. One timing, 2 warranty guarantee flowdowns.
Awesome. Okay, folks, I mean, we are kind of running a little bit over time, but should we try and squeeze in a couple more quick questions? Is that okay with you guys? And then we'll call it a day there. But I think something you mentioned earlier on was around augmentation, and I guess that feeds into the lifetime of the project and how the use cases, the applications might change over time, and the different cycling profiles and what have you. So we see those use cases for energy storage still evolving. These systems will likely live long enough to see significant changes in the wholesale market structures that they play into. So, just wondering if you've seen examples of companies successfully negotiating flexibility into their warranties to allow the owners to adapt to future duty cycles that might come further down the line after it goes into operation.
Yep. Yeah, sure, Andy, I can take this one. So yes, battery OEMs are they're already kind of forecasting that sort of flexible warranty within their system. As use cases have been evolving, they understand that flexible warranty, flexible guarantee will come up. They won't offer it. I'll tell you that. They won't offer it. Go to them, ask for it. They have that available. Work with them on a matrix. So, hey, if I use this battery 360 cycles a year at a 40% state of health, I'll get this degradation profile for this month, or this quarter, or this year. If I use an average of 720 cycles per year for this month, quarter, at 60% state of health, this is what happens with my degradation profile. And then you can map it out depending on where you see fit. You don't want to go outside those bounds, because as soon as you go outside any of those bounds, and there will be bounds, whether that be state of charge, whether that be temperature, kind of go hand in hand of sorts, because sometimes if your state of charge is too high for too long, it may increase your HVAC load. If your HVAC load is not properly sized, it may come into issues there. And if there are a warranty claim, that battery OEM can say, hey, you're out of temperature band for these few days. We're not going to warranty your system. So yes, flexible warranties, flexible guarantees are there. There will be bounds. Make sure you stay within those bounds. Think about what you want, not just for today, but think about what you want in the future. Obviously, your PPA. Your PPA is a good floor to start off with, and then look into ancillary services, your market. Reach out to third-party consulting firms, and get their thoughts and ideas of what that particular region may be looking for in the future as far as use cases go.
Excellent. And just to finish us off, I think it's pretty important to talk about safety. We had a few questions from audience members around that as well. So someone was asking about the appropriate safety standards, things like that. But fires. Yeah, I mean, we hear obviously that fires kind of become more rare the more the technology advances, but the industry obviously scales up so much that, well, you can kind of all mentally do the mathematics on that. But yeah, ultimately, it's really important to be on top of fire safety. So what are the key steps during procurement that owners in particular can take to mitigate fire risk?
Yeah, sure, Andy, I can take that one as well. So where all four of those phases, when I talked about earlier. So first, starting off with the request for tender, you can see what their past history looks like, if any, thermal events, and what were the actions taken based off those thermal events. What were the lessons learned off of those thermal events? Phase number 2, technical due diligence. So, firm may not be, seller may not be, forthcoming with their past activities. I don't know, but hire that third party to take a look into what their past thermal events were, if any, what their remedies are. Do they have practices like emergency response plans? What does their FAT protocol look like? Do they test for these fire safety systems that are in the cabinets? So you want that third party to take a look at everything. Phase number 3, which is contracts. So in case a thermal event were to happen, again, point to the contract, those troubling times, point to the contract for the correct action to take. Who is responsible for what? Phase number 4, which is taking a look at the factory. So a lot can be told about that factory audit. So look at their SOPs, look at their health and safety plan. A lot of times, if you look at their factory, that's almost you can draw kind of a line from their factory, how their factory looks, what their SOPs look like, how organized they are, to what their product looks like and how organized their product looks like. Inline production monitoring. So we'll monitor that product being built throughout that entire process. Very important. We'll look at the quality steps, the actions that are being had on that product that's being put through the line, and factory acceptance test. Looking at the gaps, if any, of that factory acceptance test, because not only they're going to test like a capacity test and up and down, but they're also going to test the fire safety system. What's their communication protocol look like to go to the enunciator panel that's going to be on site? So we want to look at all that throughout phase 1 through phase 4 to help mitigate any thermal event.
Yeah, of course. And Aaron, anything kind of you've learned from the sort of big picture view of the industry on safety?
So I think it's like you said before, the actual incident rates that we've been seeing as the industry increases in size have been going down. And we've been very lucky that it's been years since we've really had a thermal event that has resulted in injuries. And part of that is due to, better best practices from the manufacturers, but other parts have to do with the fact that we are now seeing more stringent enforcement of UL standards and other third-party standards. And I know when I came into the energy storage industry, NFPA 855 was still in draft. So there really has been a lot more sophistication in standards and what manufacturers and integrators are held to compared to even 5 years ago. So we are seeing things getting safer, but we want to continue to drive towards zero incidents because, of course, we not only need to worry about safety and about damage to property, but also about perceptions of the industry.
Yeah, absolutely. Okay, folks. Well, thank you so much for being so generous with your time. Everyone involved, I think, from the audience that offered up such amazing questions. I think all of us here would quite happily probably just keep answering these questions as it is, but just can't keep going forever today. And as I said, CEA will get to everyone that asked the questions and continue those discussions and those replies offline. So with that, I really want to thank you, Jeff, and thank you, Aaron. Thank you so much for your time today. And most of all, thanks so much to our audience and to the readers of Energy Storage News who've joined us. Have a brilliant day, and we hope to see you soon in another webinar or an event. Thank you so much.